Water. Well, what do we need water in our bodies for? Well, pretty much it makes up 60% of our body, plus a whole bunch of other things. And that's what we need to cover in this video. Water. Now, our bodies are more water than anything else. It's more than 60% of our body weight is water. And that's that way across most animals as well. Really, water is the most abundant nutrient we have in our bodies. So we have to figure out, why is it so important? What does it do for us in our bodies, as well as also what is it doing in a nutritional standpoint? Because water is essential for life. You can't survive very long without water. I mean, even just think about one day, if you don't drink water, you get pretty thirsty pretty quick. The body needs water. It's essential for fluid regulation. It's essential for balancing off nutrients. It's needed for a whole bunch of different things in our bodies. Now, water has some interesting traits and properties. We know that water can be in 3 different states of matter: solid, liquid, and gas. Now, the reason this is interesting is they can all happen within a given environment. You don't need to have a super hot environment or a super cold environment. It's just our everyday environments can cause the 3 phases. Now, in the case of solid, we're talking about ice. Ice is unique because it's less dense than the liquid form, water. Pretty much in ice, the molecules have spread apart and then in this case frozen in place. While liquid, the molecules are closer, but they're still moving around. They're kind of bouncing off each other. Gas, the molecules are very active. They're zinging all over the place, moving around very quickly. So if we're trying to compare the liquid and the solid states, for example, think about if you're standing in a crowd, just standing still, people walking past you. Are you constantly getting bumped? No, you kind of have this little bubble around you that people kind of just veer around because you're stationary, you're right there. You've had this own little environment. But in the case of water, imagine you're walking in a crowd. You're probably not bumping shoulders with people here and there as you move because everyone's moving, there's no set space. That's water and that's ice. Water is the constant moving. Molecules are bouncing off each other. Ice, though, is a set state. All those molecules are frozen in place, but they've spread out a little bit to create their own environments. So all this water. Now, in our bodies, we're looking at the liquid form. We don't really have any of the ice. We'd be a real problem if we did. But we do have water vapor already, the gaseous form. So we have the 2 different forms to look at in our bodies. And these 2 forms of water are going to help control many different body systems. They play a whole range of functionality across that as well. It's also why it's so important to make sure our nutrients from water, make sure that we get all that nutrition coming in, enough adequate water. Take the cardiovascular system, for example. Blood. Blood has a huge percentage of water. Could you imagine blood if it wasn't liquid? Not happening. You'd have this sludge kind of pushing through the arteries and veins, and it wouldn't work. Water's essential. Now, what is water really? It's 2 hydrogens and oxygen, H2O. And those 3 individual pieces, 2 hydrogens and 1 oxygen, they aren't really sharing these electrons evenly. The oxygen is going to have a little more of a pull. That means that a little more of the negative electrons are going towards the oxygen compared to the hydrogen, which means that the oxygen has a partial negative charge to it, while the hydrogen, they'll have partial positive charges. The reason I mention this is because those partial charges are going to help with one of the traits of water being a solvent we'll talk about later. So remember that oxygen is a partial negative, hydrogen's partial positive. And we know that opposites attract in the case of molecules. So they'll come back to that one later in the video. So how about a few of the interesting and special traits? One is called cohesion. Now, in the case of cohesion, it's when the same molecules like to stick together. I'm willing to bet you've probably seen water droplets. Water lands on something, maybe mist in the morning, dew. Those water droplets are domed. All those H2O molecules are clumping together and sticking together. That's cohesion. A second trait is going to be adhesion. Now, adhesion is going to be molecules sticking to different molecules. So in this case, think about when you're sweating. The water molecules are on your skin, little droplets of sweat. They're sticking to your skin until enough form they start to run down. That's adhesion, and the actual droplets are cohesion. Another trait is heat capacity, and this also goes back to sweating. Water has a very high heat capacity. Now, what actually is heat capacity? Well, heat capacity is going to be the amount of heat that is necessary to change one unit measurement in a certain mass of a particle. So in this case, water. So pretty much, you need to have a lot of heat to change the water's temperature. Water is great at absorbing heat. That's how our sweating works to cool our bodies down. Because our bodies have all these sensory neurons, head to foot. These sensory neurons will say, hey, we're a little too warm here. That information is sent up to the hypothalamus. Hypothalamus, up in your brain. Completely autonomic control here. We're talking things that you don't even think about. It just automatically does it for your body. So say, okay, we're too hot. Let's start the process of sweating. Well, sweating is using water. You're going to have the blood flow into your skin. The heat then is transferring from the blood across the skin and into that water that's going onto your skin surface. The water evaporates, taking the heat with it. So water itself has a very high heat capacity. It's great for helping our bodies to cool when necessary. Another trait. So we've gone through cohesion, we've gone through adhesion, gone through heat capacity. Next one up is capillary action. Now, capillary action is going to take both the cohesion and the adhesion and put them together. This is important for all the plants we're eating. Now, any of those leafy vegetables you eat, or think about the fruits coming off the trees. You have to somehow get the water from the ground, the roots, up those plants into the fruits or up into the vegetables. That's capillary action. The water is being pulled up these tiny little tubes inside the plants. So again, another interesting trait of water. Switching back over to the human side more, looking at solvent. Now, sure, solvents can be anything, human or outside of human bodies, but for our bodies, there are a ton of different molecules that get dissolved in water. Water is a great solvent. It's going to allow all these solutes, all these molecules, to dissolve into the solvent, which is water. So why do we care? Well, things like salts, electrolytes are being dissolved in the water. By doing that, you're helping to control those levels as well as distribute throughout your entire body. So this whole idea of water being a solvent is very, very important. When you're thinking about salts, sodium chloride, NaCl, well, when salt is in its natural state, it's a crystal, but put in water, it dissolves. The water is the solvent, the salt is the solute. When that salt, that sodium chloride breaks down, you get sodium and you get chloride. The sodium is going to be surrounded by all the oxygen molecules. So that means you have all these waters with the oxygen going around them. While the chloride, being negative, is going to have all the hydrogen molecules of water facing towards it. That's why I was mentioning before about that partial negative, partial positive. Here's what comes into play. Because depending if the molecule breaks up into a positive and negative, or just you have extra molecules around, whatever the charge is which part of the water is going to be facing it. This also comes into play when talking about the cell membrane. Because some things love water. They're hydrophilic. Hydrophilic, water loving. Some things hate water. Hydrophobic, phobic, afraid of. So hydrophobic is afraid of water. In the case of your cell membrane, it's going to be a double phospholipid membrane. The two faces out are both hydrophilic. They love water. All the tails facing in are hydrophobic. They don't want to be near water, so they're facing in against each other. So your cell membrane is built so the water can touch the outsides, hydrophilic, but the water can't touch the insides, hydrophobic, water hating. Well, some other helping things. Proteins. We've already talked about proteins, how they're built from amino acids. Well, some amino acids are hydrophilic, other amino acids are hydrophobic, which means these amino acids that are hydrophobic will try to fold inwards and allow the hydrophilic amino acids to face out. This helps to create the three-dimensional shape of a lot of your proteins. And that's important because proteins become fully functional once they've obtained their three-dimensional shape. So water can actually help these proteins to go into their final form. Well, we also mentioned water and pH. pH is going to be going from 1 to 14 is the scale of pH. 1 being very acidic, 14 being very basic. You're saying, well, what does it have to do with water? When you put an acid in water, so that acid dissolves into water, it's going to release hydrogen ions, H+. Those H+ molecules will bind with water to create H3O+. That's a hydronium molecule. That's moving from the neutral of 7, moving it to a more acidic nature, down to 6, 5, 4, 3, 2, possibly even 1, very acidic. But if you put a base into water and dissolves in, it's going to release OH negative molecules or hydroxyl molecules. These hydroxyl molecules are going to change that neutral pH from 7 to 8, 9, 10, 11, 12, possibly even 14. More basic. So the strongest acids release the most hydrogen ions. The strongest bases release the most hydroxyl ions. And the reason the pH is so important in our bodies is because most of our systems are very, very sensitive to pH levels. Take your blood, for example. Blood needs a pH between 7.35 and 7.45. 1/10, 0.1, that's it, is the range we have to maintain. That means we have a buffering system in our blood to help keep in that range. A buffering system is a reversible reaction, where if it gets a little too basic, it goes one way, or if it gets a little too acidic, it goes the other way. The reaction will help to shift back and forth and absorb the excess ions, hydrogen ions or hydroxyl ions. And by doing that, it helps to keep the pH in the range. If your blood pH goes below 7.35 or above 7.45, then we start to have a whole bunch of health problems and chemical issues in our body. And that's just one system that's dependent on pH, which is dependent on water. So water, very important again. Another thing for water, cushioning. Saying, well, hold on, water cushions, sure. In our bodies, we're going to have synovial joints. Synovial joints, things like the shoulder, the elbow, hip, knee, even your fingers. These synovial joints are filled with what's called a synovial fluid. Helps to cushion the bones from interacting. Another example, brain, spinal cord. That's going to have cerebral spinal fluid around it. Based on water, again, that helps to cushion the brain from impact. If your brain hits something quickly, that slows down the movement of the brain so it doesn't slam against the front of your skull. So cushioning in your body. That's coming from water. We also have mucus production. Now you're saying, oh, mucus, yuck. Well, mucus, there are mucous membranes throughout your entire respiratory system, your digestive system, parts of the reproductive system. I mean, there's mucous membranes everywhere. These mucous membranes are helping to allow the passage of substances past them. So it helps with the processes inside. It also helps to prevent pathogens from getting into your body. The mucus will trap them, and your body gets rid of them. So really, your water in your body, yes, you're thirsty, but there's a ton of things that water can do. And it's also one of the reasons why it's so important to regulate your water, to control how much you have and make sure you have enough. Until the next video.